Hello people. So this one is the first video where I want to start talking about, pose assets, corrective, solvers, and stuff like that. Is It's a complex subject. I'm going to try to put all these words that you see here in order, because it took me a while just to transfer what was my knowledge in my previous industries into Unreal kind of workflow and wording. Um, so let's start. So we know that the end goal is to have a good-looking, kinematically sophisticated deformation rig. That's cool. That's a good word. We're going to put this at the end. So at the end of the day, whatever is deforming the mesh or transforming the mesh or anything, it's mostly, it's a skin cluster deformer. It's a blend shape. We also mentioned good looking, so it could be a material or it could be an attribute. All right. So this is the stuff that makes in the end is what we manipulate in order or we drive in order to make the character move around. And let me just put these in here. So these are deformers. Let me grab. These are the linear deformers. And these are just an implementation of an algorithm that through certain relationships is moving points around, right? We saw them in the past. This is just the skin, which is attached to the bones, and it's a relationship to the mesh. And then there's a relationship between targets and the mesh itself. So both of them are moving points linearly, and we'll see why this is important to say. And then, something else that can define the good looking of the character could be some custom uh, stuff, a material moving, like we want to say that every time I don't know, the left arm stretches, it just becomes green for some reason. So this is additional additional data. Okay. So the goal for to have a good rig, you can build a rig that is like a puppet, whatever we have been building so far. You have a biped and you have a control rig that drives the skeleton, some blade shape, etc. But this is a kind of a direct manipulation. Even if you're using IK, yes, IK is inverse kinematics, but technically what you're doing is moving the control rig. The control rigs move bones in a certain way, and there you have it. You have the bones are attached to a skin cluster weight, and the skin cluster is deforming the mesh. Same with the blade shapes, etc. But in order to improve the deformation quality of of your character, but not just the deformation, but in general the behavior, you probably want to have something a little bit more complex and establish more relationships that are the ones strictly speaking directly correlated to the control rig. For example, you want to have angles or bones or attributes driving some other joints that are not part of the main solving for the main body. Okay, so all of this, let me move this thing around. It's part of the idea of augmenting um, the quality of the rig. Okay, and this is one of the goals. And you know, another goal could be could sit under the name of building a corrective system, and we're going to see what a corrective system is. So in general, starting from at the very end, if this is the goal and this is the implementation that you need to use, um, what you need to figure out, it's a way to build something, a system that allows us to augment the quality of the rig. And this could be what we're going to discuss today is let me get rid of those three dots, really annoying. What we're going to discuss today is how to build the system in a very simple manner. So this is just purely, the theory behind it. Um, okay, so let's start with an example in Maya. And I use Maya, again, every time I jump into Maya in these videos is to make the point that this is agnostic to the DCC itself. I know this is Maya, I'm just more faster in it, but um, this is a concept, okay? So we have the cylinder, and this, you can think this of an arm, upper arm, lower arm, and we have joints, and we rotate the joints. And because this is the classic problem of the crunching of the mesh, because the skin cluster is linear per se, it cannot resolve the volume preservation. So a standard technique is in rigging is, for example, a corrective. And corrective is just a concept, but it's the idea that we want something to happen when, for example, this rotation is happening. We want something to happen that fixes this pose. And one way would be to build a blade shape and say, okay, every time this joint goes from here to here, we also trigger a blade shape that fixes, for example, the elbow and the inner part of the arm. That's one way. Another way is, well, maybe if I rotate the bone like this, I also want these bones to basically move in a completely different way that fixes the problem. And you see, I'm talking about a specific technique, a specific implementation. And this is at its core what we need to pick when we try to address these things. Both of these techniques are part of the corrective system. We are correcting something by triggering something. What is that something? It could be a skin cluster, usually, or a blade shape, usually. But the cool thing about a corrective system is if you think it in an agnostic kind of way, it could trigger both. Okay, so having, to me, the fact that we're fixing this through joints is just an implementation detail. I don't really care about the fact that I'm moving joints, but rather I care about the fact that I'm triggering something with something. This could be a blade shape, it could be joints, or it could be both. Now, why am I saying both, and why I think both is good? Well, this brings up another word, and this is where I wrote down linear. Let me find it. Non-linear. Okay, this is something that is purely based on my experience, but if you analyze what happens on a human body or whatever, even a cartoony, what makes a good looking deformation rig is a movement that it feels like there is a structure under the hood that is interconnected, and there is flesh and bone pushing and pulling depending on the volume, depending on the stretch, etc. These deformers per se, they are implementing linear deformation. A combination of these two, though, if you apply certain bones transformation plus a manually crafted blade shape, if you combine these two, then you can fake it and make those two linear deformers to look like they're moving in a non-linear manner. When you're smiling, you're pushing the cheek, or there is a slightly delay in the flesh, or maybe when you're rotating the bone, there's a slight delay on where the muscle is pulling. So it feels like there is a structure under the hood, a muscle here and there. That's why I'm saying the best result you can get is by combining these two deformers together. Okay. So, and then we said, okay, so this is a goal. Okay, so let me put the goals are in blue. This is something to keep in mind when you're designing your kinematics and your deformation, okay? So all of this is to have a system that creates more sophisticated relationship between what's happening in the control rig at the very beginning up to the very end of the chain, which is the final result. Now, this works as a corrective system, for example, for a fleshy character. In this case, we're triggering blade shapes and bones, but this is also true to augment the quality of the rig. So these two, again, are mostly like, this is a goal, and this is a system. But it's the thing to keep in mind is that what we're going to discuss today is something to address this and build something that is related to corrective and in general augmenting the quality of the rig. So if you wanted it something like this. Okay. So, and a rule to keep in mind, a rule of thumb, is try to achieve something that makes it more believable by implementing a type of deformation or a type of movement that is nonlinear, especially for creatures, or for fleshy beings. Okay, so so we saw this in Maya. I rotate the arm and then I'm gonna correct it by doing that. Now this, I'm basically posing the rig, and here's another very strong concept. So it means that when I rotate that from here to here, I want a certain pose to happen. But pose is an abstract concept. I don't want you to think pose is like joints or it's just blade shapes. It's a combination of things. A pose could also be a certain material being triggered, or a certain custom attribute be triggered for whatever reason. Okay, and this is where I would like to create and put these under the concept of pose. And the pose, it's an abstract way of thinking, while the skin cluster of blade shape is a specific technology implementation of deformation that allows us to reach a pose. I hope that it's clear the difference. The pose, it's something that could be, you know, this joint in this specific position, this joint in this specific position, plus a blade shape, plus the color getting more red. The combination of these linear attributes is what it makes a pose. And a pose usually is associated with a weight, exactly like a blade shape. Okay, so a blade shape that goes from 0, this pose is not applied, and when I put it to 1, this pose gets applied. But rather than purely be on a blade shape or a morph target, it's moving more than that. Okay, now let's talk about why I think the combination of these two is quite important. So, and I want to talk a little bit more about nonlinearity before sorting all of this stuff out. Well, let me get back to this. You could say that when I rotate this, I simply want to sculpt a blade shape that fixes this. And let's do exactly that. Unlock, move here. I don't like this pose, so what I do, I sculpt this, and I sculpt this, and then I do something like that, and then I do this, you know, my amazing modeling skills. Okay. Okay, let's say this is an amazing sculpt and this fixes that. Okay, this is a blade shape. This is a morph target. I can apply to that and say every time this guy rotates, I want this to be triggered. Cool. Now let's see what happens when I move this on top of the mesh. You can see that the difference between the origin mesh, or the starting point from which this blade shape should be triggered, is quite high. This amount of displacement, it's high, especially on the corner here, from this position to this position. And it might not look much here, but when you're interpolating between this position to this position, and you're slowly triggering that, this delta, this difference will make it look, the mesh will look bad while it's interpolating. And this is because the deltas are quite high. So this is one way. But what if instead of doing that, we also have joints, and I position the joints like this, and then I duplicate this, I unlock this, I put it here, and then I fix this to make it a little bit more, to have a blade shape that looks a little bit nicer. I don't know if this is nicer, but you get the idea. Now let's have a look at the difference. So you can see that the difference, especially here, it's quite low. The delta, it's low. The amount of displacement, it's low. This will result in a much better interpolation. So this is why a combination of the two systems is usually the preferred way. You want to have the joints to carry most of the big broad deformation and the blend shape only taking care of the details. For example, if you want to really have the idea of an elbow here, a bone, or maybe have a bulge of the muscle here. This is the amount of details we're interested in when it comes to blend shape. But the broad, big volume and masses, it's better if it's carried from the skin cluster. And you can see that in MetaHuman as well. This is a kind of common technique. Okay, so this is where I wanted to go a little bit in detail about why this is good. To combine these two things is good. Okay, so we said we want to implement a pose, and each pose is basically a combination of materials, joints in positions, or blend shapes. Basically, the pose makes the mesh look like this. Good. Okay, the pose can be triggered by a value which goes from 0 to 1, exactly like a move target. That's great. Okay, now how do we drive this pose? And this is part of the corrective system, and or to augment the quality of the rig. It doesn't. I'm splitting these in two because I don't want you to think that this system is only for muscles or fixing things. This can also be used to define how a robot and transform itself. It's not just necessarily corrective. In fact, these two things usually sit under something else, and this something else is I don't have it. Great. You may have heard this as a concept that we are going to call PSD. This is an overall structure, or a pose-based deformation, which is, it's something that implements a system that allows you to drive poses with a certain rule. Okay? Now let's figure this rule out. Okay, so we know that the pose, it's something that we specify, we author, and it looks like this. And at a certain point, we want it to be driven. What we want is to have a rig that when I rotate this arm, automatically this pose gets triggered, automatically. How do we trigger that automatically? It depends on our corrective system, or how we implement the PSD if you want. So we know that the pose are our driven stuff, okay? Well, if something needs to be driven, we also need a driver. Okay, and for example, to give you an idea, the driver in this case is the rotation of this, is the Y value on this bone. We say when it's 0, nothing needs to happen. When it's 90, something needs to happen. Okay, so this is our driver. And then what do we need to do is to find a relationship to drive something with something, but how? So as you know, rigging in general is about creating relationship and rules to drive something with something. So one way would be, it could be a direct relationship. We saw this, like for example, we have a bone that goes from 0 to 1. We simply connect the rotation of the bone to whatever needs to be driven. That goes from 0 to 1. I rotate the bone, and the same value goes here. So this could be a direct relationship, okay? Or we can have a remap value, okay, where we can say the bone goes from 0 to 90, and I want to say every time is 0 is 0, the value is 0, and every time is 90, the remap value needs to output 1 and interpolate in between. So basically from 0 to 90, this node goes from 0 to 1, and that's where I drive my pose. Or I can use a driven key. You may have heard of this word. This is very similar to remap, but the difference is that the value can be it gets, while I'm interpolating between 0 and 1, the value can be multiplied by a curve to introduce slow in, slow outs. So you can have a value that goes from 0 to 90, but the output value goes from 0 to 10, but between 0 and 5 is lower than from 5 to 10. This can introduce delays and make stuff non-linear. Or if we want to go into um, something a little bit more complex, you may start thinking, you may have heard of the word RBF, where this is a much more sophisticated solver and is something that we're going to use today, where the RBF stands for radial basis function. It's something that allows you to understand and to get a little bit more power on how the poles are interpolated and interconnected between one another, especially if we need to have a predefined range of these poses, and we want to have full control over how they blend from into one another. It will be much clearer once we jump into Unreal. Okay, so all of this is we basically, at this very moment, I said we have a control rig that drives the skeleton. Okay, let's put it that way. And you could say that this is our rig. Okay, that's actually rig. Let's call it rig A. And you can see is that at the very left of this diagram. So you may like, nothing stops you to build something that basically looks like this. We have the control rig drive the skeleton, it drives some blade shapes maybe, but then that's it. But if you want to augment the quality of the rig, implement a corrective system in order to have a good looking end rig, what you need to solve is stuff like biceps, collision meshes, or the knee when it rotates, it does not collapse on itself is the classic problem, or even on a robot, whatever you can think of. So you need to solve these tiny little problems on their own through a corrective mechanism. Okay, the idea of layering this stuff together, like solving, this is the classic puppet, and then you solve this stuff and you chain this stuff together, but each individual area of the body or whatever character you have is the idea of being, to have a layered kind of rig. And this is another concept. The fact that you're representing or you're focusing the deformation on a specific area to augment it is the idea that you're layering the rig. You have the rig A, and then you implement something that drives a pose, and this could be your rig B if you want, and you chain these things together. This is the whole idea behind layering the rig. It's nothing new, but Unreal as usual does it, and it helps the user to do it quite well and quite fast. So now at last I'm going to start introducing Unreal words, because this is just concepts. So I'm going to turn the Unreal words are black. The fastest way I found to implement a pose, the way I just described it, it's something called pose asset, and we're going to see it. The fastest way to implement to have a relationship between a driver driven, for example, with RBF, it's something called pose reader. And the best, the best and maybe only, I don't know, way to implement this layered approach is through a post-process blueprint. Okay, so the black words are basically our Unreal words. Okay, cool. Let's do it then. Okay, so let me get rid of these stuff. Let me get back here. We have this mesh. Great. And this mesh, I said that when it rotates by 90, I want to have certain joints in certain position. I'm not sculpting any blend shapes, but it's the same thing. So I prepared an animation here, and you can see this is nothing. This is just bones and meshes. I placed a keyframe here, and I said, okay, when I'm at 90, I want the joints to look like this. And in this specific case, I can also add a blend shape to fix it even further, but it's the same. The concept is the same. I don't want you to think about the deformation technology right now. In this case, I'm using joints, but think about as a pose. The pose can be implemented with joints, blend shapes, whatever. As long as you know that this we're using a pose. Okay. So I'm posing the rig like this. It's just I literally keyframe the joints. I'm doing nothing else. And then I'm going to another frame where I'm pushing the geometry even in. The arm is rotated by 135, and then I'm moving the the joints in this position to fix it even further, right? Okay, so we have a neutral pose, 90 degrees pose, 135 pose. Okay, so these are two poses, three poses if we include the neutral. What I do then is I export this as an animation. Let's export this as arm. Good. We go into Unreal, and in Unreal what I have is a control rig. I'm not going to explain this too much, but in the control rig here, I simply have a control that moves the bone, a control that moves the bone. Okay, nothing serious. And you can see that nothing is going on here. Those joints and nothing is happening. Okay. What I do now is that I'm importing the animation I just exported. And I'm not importing the mesh. I'm using the skeletal mesh. That's good. Excellent. And I save it. And I'm looking through the pose, and it's amazing. This is better than Pixar and Disney. Okay. 0, 1, and 2. Great. The coolest thing about Unreal is that now what you can do is that you convert this animation into a pose asset. Create pose asset. I'm picking the animation, and then I can already give these frames that I already know a name. Neutral, bicep flex 90, bicep flex 135. I always like to append the values of the driver in here, so I can always go back to. Created a pose asset. Great. How does this look like? Well, the pose asset looks exactly like I described. This is a pose. This is a pose that can now be triggered through a value from 0 to 1. You see, right now, I'm reaching, and this pose is simply moving these joints in this position, but this could also basically move blend shapes, whatever. It can be anything, right? It could even be a custom attribute. Let's see this one. Okay, so we have these poses. So we are here. We have defined our poses. The poses have a weighted value that we can drive. That's great. Back here. Now it's time to connect the two things together. So I have my poses and I have my rig. How do we connect these two things together? Or rather, how do we layer these things together? Well, that's through something called post-process animation blueprint, which happens to be a normal animation blueprint. So I'm going to click on the skeletal mesh. I'm going to say create animation blueprint. This is nothing else than an animation blueprint, but the way I'm going to use it is as a post process. Okay. And what does that mean? We'll see it in a bit. I'm going to create an input pose. Then I'm going to connect the input pose to the output pose. This is the most stupid animation blueprint ever created in history. Okay. Compile, save. As I said, this is an animation blueprint. We're here. But the way I'm going to use it is as a post process. And what that means is that it happens to the skeletal mesh after whatever is happening to the input. So this graph, it's run after whatever it's moving the skeletal mesh, which remembers eventually is going to be our control rig. So I'm going to open the skeletal mesh and I'm going to specify the anim blueprint I just created as a post-process anim blueprint. So what this effectively is doing is that I will have a control rig that is moving the skeleton, then it's running the post-process animation blueprint to get my thing. All of this stuff here is implemented as a post-process animation blueprint. I'm hoping that makes sense. Move this bit back here. So right now I'm saying, okay, every time something happens, oops, not this one. Every time something happens here, do execute this graph, and there is no graph right now, and then output the final pose. This happens to be a my control rig. Okay, or it could be anything. It could be something at runtime, it could be another graph, it could be anything. This is part of the animation blueprint, which I'm not going to go into detail, but effectively I'm using it as a post process on the skeleton. Okay, cool. So what I want to do is now generate this relationship or create a very basic corrective system to augment the quality of the rig. So what I'm going to do is use a post driver node, and I'm going to connect this post driver here to here. I'm going to compile, and nothing, it's working. In the post driver, you need to specify the pose asset. Remember, this is the node that contains our poses. And it means now, through this node, I can now drive something with something. I can drive the driven from the driver using something. In this pose, I can say add target. And the first target, I always want to use the neutral. And the reason why I want to use the neutral is that I want to know when I'm getting closer to the neutral pose and trigger the neutral pose. This is something, it's a good habit to have. And because right now I'm only interested in rotation, I'm leaving the drive source as rotation. My source bone, in this case, is our lower arm, because we said that. And let me open neutral. What all of this UI means is that my driver is the lower arm rotation. My rotation, when is at 0, trigger the pose neutral. So all of this so far means nothing until I add another pose. I want to say bicep flex, which is this pose, and you can see that it's triggering it because these values are at 0 and these values are at 0, so it's 50% on neutral and 50% of bicep flex. So what I need to do is say, no, I want to see this only when the rotation of my source bone is 90. And you can see now that it went back to 100 here. Let me add the third one, which is our bicep flex here. And in here, I think it was 135. So now you can see that because there is nothing going on here, our rotation is 0, we are getting 100% of the neutral pose, which is absolutely fine. But how do we get from this position to the corrected pose? Well, this is where in this specific pose driver we're implementing the RBF. Okay, and the RBF, part of its attributes, it's the area of influence of which these poses can travel from one another. So if I increase this radius, you can see these cones. And the red cone is basically the pose we are pretty much currently on. And you can see that if I intersect them, I'm basically starting to get the bigger the radius, the more the values get distributed from one pose to another. Right now, we're not 100% anymore. We are 1.1 on bicep flex. Why? Because this cone is getting closer to this cone. This cone represents the 90, this cone represents the 135. So if I keep it like this for now, and I go back to the control rig, the control rig now says there is a post-process animation blueprint on the skeletal mesh. So we apply the animation blueprint to the skeletal mesh as a post-process animation blueprint, and control rig has recognized that, and it says, do you want me to show you the final result or only the results of the control rig per se? So right now I'm only seeing this. I'm only seeing this. Well, both. But what I want is to see this plus the post-processing that is going on here. I'm going to enable it. And now you can see that something is happening automatically. So from here, I'm rotating from 0 to 90 and to 135. So you can see that finally I'm augmenting the quality of the rig by layering an additional behavior through the animation blueprint. And over here, I'm solving the specific problem of the bicep through this reader. If I increase the radius, the more these cones will overlap. Where is it? The more these values will be distributed. You can see that by intersecting these cones, I'm also giving a little bit of weight to the bicep flex 135. So it's really about making sure that you get a good average, because if you may think that you want to reduce these so they will never overlap and you get full values. But what happens then is that in between it doesn't know where to interpolate, so it falls back to whatever is going on. So you can see that you have neutral. I don't know where to go. I don't know where to go. Oh, I'm getting to 90, and then I don't know where to go. I don't know where to go. I don't know where to go. Oh, I'm getting to 135. That's why it's always better to intersect them a bit. And it's a matter of going back and forth. Now, additionally, if you don't want to keep constantly going back to control rig, etc., you can also have something where you simply load. Where is it? Just a rotation of the bone as an animation. This is just a trick. You don't have to do it, but I like to do it, not to constantly go back and forth with the control rig. So this animation here, if I remove everything, this is simply this animation. All right. Oh, come on. Up. You can see nothing is going on. I'm not correcting. What happens if I feed this here and then this here? So this node here, I'm only using it not to jump onto the control rig. This represents the same thing that I'm doing by manipulating this control. You can see that now it's broken because I haven't connected the input pose, but that's fine. So if I move this, I can easily check what's going on. And it's like, oh, here is pretty bad. So what I need to do is go back to here and increase the cone until I like it. And let me scrub it through. Well, that's good. Okay, and then I'm getting back here. Once I'm happy, I can simply go here, get rid of that, compile, and compile again, and boom. Well, that's not perfect, but the initial model is not good to start with. I'm hoping this video makes sense. I'm hoping to be able to make more video about poses, because this is the core to get your rig to the next stage, to the next level when it comes to performance, to quality. Thank you for listening. Bye bye.